Good afternoon. This is Dr. Polaiah, working as a professor, Department of IT, Institute of Aeronautical Engineering. I'm very happy to share my video lecture today, that is on the topic Basics of Full Color Image Processing. Once again, I'm repeating, today's topic is on Basics of Full Color Image Processing. I hope you are all very aware about image processing, but we are concentrating now the basics of full color image processing. So that is very important. So coming to the basics of full color image processing approaches fall into two major categories. What are those two major categories? Number one, the approach that processes each component image individually and then form a composite processed color image from the individual processed components. That is the first one. Whereas second categorization of the full color image processing is approaches that work with color pixels directly. In full color images, color pixels really are vectors. For example, in the RGB system, each color pixel can be expressed as in terms of matrix. So what do you mean to understand is here, you once we have gone through the basics of color, full color image processing, where we are categorize this basics of full color image processing into two categories. That two color categorizations are very mostly we are going to be used for the sake of preparation of your color image processing. So here your color model preparation of color model full color image processing, that how we may prepare in the sense the image which you are taken, which you are taken, it may be 2D image or 3D image. Okay, such an image 100% has to be concentrated on your complete size of the image. That is m by n. So usually we'll write with the capital letters. So notationally we'll write with the capital letters. That is m by n. So what we want to understand here, a 2D or a 3D image, which is you are taking a 2D or a 3D image, which you are taken into the consideration for preparation of any color model, we must have to concentrate on the size of the image, which you are measured in terms of notationally m by n. So that mn such vectors, mn, m and n, such vectors we keep into the concentration of changes in terms of x and y. That is the objective function which we call is a c of x comma y. So this x comma y, which we are going to be making to the satisfactory function in terms of x, that is for x equal to 0 or x equal to 1, which help us in terms of your mn are the vectors. Okay, if not, then we may going to consider m minus 1, where y values are changes into 0 to n minus 1. So these two categories are important. One is mn such vectors in terms of c of x comma y for x equal to 0 comma 1 and or we are going to use the second one, that is m minus 1, we are keeping into the y values variation, that is your image is right now x and your image keeping into the y. So when you are keeping into the y, x and y Cartesian coordinates values which are various in respect of mn vectors. That vectors of values are varies object function comma xc comma c of x comma y. Okay, so this objective function which we are concentrating is here is we are going to be keep on to understand in terms of x and y Cartesian coordinates values. So that x values how it may vary with respect to mn vectors, we keeping in the either x equals 0 to 0, 1, etc. But where with respect to y, we are going to be called as 0, 1, 2, so on n minus m. What is m here? What is n here? M, n are the vectors which are depends on the your selected image size. Image size or provided image size. Okay, so that value we are keeping into the color image. This is the color model. Color model. So what is your color model here? Your color model is here. Your color model is here, which is depends upon your C of x comma y of matrix. We are keeping into the conversion into the color, that is CR of x comma y in terms of pure red. This is red model. This is red color model. Red color model value. That red color model value. Okay, red color model. So next G is the you are going to have the green. What is this? Green color model. Green color model. Where is the blue? Blue is the blue color model. Blue color. So what you mean to understand is here is you are going to be concentrate your basics of full color image processing, which is keeping into the your required color model based on the selected size of the image is one point, and the second point is the size of the image. Once you selected, then automatically you know the vector values of the size in terms of m and n, which are help us to define object function of c of x comma y. Once we define that, then go to the third point. You are making that size of the values of an image into your required color model in aspect of keeping towards to you in terms of red color, green color, or blue color. So such a way we are going to be concentrating here. Such a way we are going to be keeping into the here. Okay, I hope you understood this slide. Next, coming to the such a basic color, we are going to be preparing a model, but we have to concentrate here. Depends upon your size of the image, your either 2D or 3D image. Okay, this image size we are going to be keeping in terms of pixel values. That is second categories. That is you are going to be making into the this image you are going to prepare in terms of pixel intensity values of changes. So how can you change that? Okay, how can you change that? How can you change it? So you are going to be change that in terms of neighborhood averaging values. Okay, neighborhood averaging value. So what is the neighborhood averaging values here? You are keeping in terms of your selected image size is x and y. Okay, so in this you are going to be find out your spatial mask of the value from the your selected image, which named as a grayscale. Now the grayscale is converted into color model image. So what is the grayscaler image? Grayscale image is nothing but you are going to be used in terms of black and white. Okay, so that black and white image is converting into your required color model of the image. How you are convert that? You are going to be use the RGB color images values. So once you are preparing that RGB, here you are going to be keeping into the spatial mask, that is x comma y, which are varying in terms of RGB color model. This is your grayscale image. Okay, this is your RGB model. RGB model of the color. So how you are going to keep? You are going to be keep changes in terms of your changes in terms of your required color. That is RGB colors. So that is what it is varying. That is what it is varying. RGB models of the color. So once you are using this, we are going to be prepare your required formulation of the your image, which is depends upon the your you are applying one of the method is named as neighborhood averaging method. What do you mean neighborhood averaging method? It is comparing your while you are converting your grayscale image image to color, you are converting in terms of applying the one pixel is compared with the another pixel. One pixel is converting with the other pixel. So like that we are going to be concentrating is here. So neighborhood averaging is concentrating on one pixel with another pixel comparison. Why you want to do that? What is the major advantage of this neighborhood averaging is redundancy of the pixels will be reduced, and the more while you are converting grayscale to grayscale image to color image model, you are concentrating much more quality of the image. That means your full color image processing is right now quality. That means you are going to be avoid redundancy of the redundancy of the pixel values. Okay, so now that formulation. So while you are making such a formulation is here, you are going to prepare such a formulation according to the your required conversion of black and white to color, full color model. What is the formulation you are applying here is you are going to be concentrating on color transformation, that is model color transformation with your connecting of your that what we call is your grayscale image is converting into your color image. Your this T means transformation, color transformation. What does it mean T? T is nothing but color transformation. So G of x comma y is equal to T of f of x comma y. That pixel values are here. We are concentrating on triplets or quadrants. So you are concentrating the pixel values which are concentrating in terms of have a neighborhood averaging method process in terms of triplets or quadrants. Okay, so once you are concentrating while converting while transformation from grayscale to color, your transformation 100% depends upon the analysis to selection section of your grayscale image, gray level image. As we consider that, let us assume this is one of the this one is suffix, that is Si is equal to T suffix of I, where R1 comma R2 so on R suffix there, where this I is varies 1 to n values. Okay, so these values, what do you mean to understand here? Your analogy to section color, that is your G of x comma y is right now converting T of f of x comma y. This is your transformation. This is your transformation. How your transformation is? You are going to be concentrating on the formulation. Formulation which help us in easy manner to convert your grayscale image into color image. That is the what we want to understand here as a full color image process. So, for example, let we can take your full color image processing, which are right now these are the grayscale image. These are the grayscale image processing. So your achievement is right now color mode. Your achievement is right now is color mode. So how you are converting into your color? This is your black and white. is right now converting into color. Color model is, what do you mean color model is here? RGB. How you are converting? Sound depends upon your formulation. What is the formulation is here you are using? S transpose S of your x comma y of the image is equal to transformation of f of x comma. So what is this? What is this I? Where I is changes 1 to n values of the your pixel intensity of the values. So that values which varies here for transforming into your color transform. That is your color transformation happen here. Your color transformation happen here is Si of x comma y, that is equal to Ti of f of x comma y. So that is very important is here. That is what we want to color, concentrating. Your grayscale image processing is converting into full color image processing. Let us assume, let us see the colors how it is, pixels are varies from one to other. How the pixel, once the pixels are varies, your image visibility also varies. You see here, being it is a black and white image, that is grayscale image, the pixels depends upon the pixel intensity. Pixel intensity varies, automatically your colors of the image will be. So which type of color is here is the obviously as it is, then that is, so that is what we want to understand is important point is here we are, while you are converting, you are going to check in terms of neighborhood averaging process by the help of your formulation. So coming to the point that are when we are transformation from SI to, that is your selected object function of the image from grayscale image to grayscale level of the image to color levels of the image, that is color models of the image. How you are going to apply? By the help of certain operations, some operations that are better suited to specific models, but cost of converting between representation has to be considered as well. That is, for example, suppose that we wish to modify the intensity of the image pixel values using one of the formula, that is g of x comma y is equal to the k values is varies, where k is the varying in between 0 to 1. So what is this K? Its K is the color model which help us, depends upon your K value varies in between 0 to 1. In between 0 to 1, that is greater than 0 and less than 1 value. How many values will be there in between 0 to 1? That means K is greater than 0 and less than 1 means positive values. Positive values you can vary according to their requirement. For example, I have here 3 color models. What are those? 3 color models here. So one is HSI color model. That is, we are assigning S1 equal to R1, S2 R2 as to K. So this K value is very here. Whereas RGB color space, your SI, that is simply you can say S transpose SI suffix I is equal to some K constant, that is proportional constant of R suffix I. What is this? So here we are varying this Ri values, then corresponding output of the imagery which we are converting is also various. But condition is here you are keeping into the your K value assigned in terms of satisfactory condition. But whereas the third color model, that is the CMY color space, it is very easy, but that variation will be happen here little bit different. What is that variation is? You know RGB. Then you convert that CMY. How this RGB color model can convert into what we call CMY in the sense, here is your formula. That is Si is equal to K into Ri. That is K into R suffix I into K 1 minus K. That the values are varies with terms of that values are varies of I 1, 2, 3, so on n. So coming to the one more important slide, which we can understand that how this HSI transformation involves fewest number of operations. The computation required to convert RGB to your required RGB to you're converting your CMY of K image to the HSI space more than offset. The advantage of the simplest transformation is here we are going to be understand each and every levels of the image processing. Even in our day-to-day life, where we can also observe some of the application of this full color image processing, we can adjust the color. We can adjust the your color, that is your RGB color process. How can you adjust this? You can adjust according to their adjust your grayscale image is converted into your required. So that means depends upon your selected sensor also very important. Sensor also very important. What is the sensor here? Camera. So your digital camera which you are using to capture the image and make that image process towards to understanding levels of the image processing is we can apply it by the help of combination of the Laplacian Laplacian of Gaussian, that is LOG operator, with a spatial filter that maximize the contrast sensitivity functions of human visibility system. So these are the very one of the visibility system. So visibility will happen your sensor. Your depends upon your sensor, which is we are consider right now is a digital camera. Digital camera we are using. Okay, so that is very important is here. So we can extend this color image processing in terms of smoothing and the sharpening also. In terms of smoothing and sharpening. So we done some of so students are done with the help of MATLAB simulation how you are converting your selected image through the your selected camera sensor to required. We can do sorry we can do this. We are going to be what we can understand that we can make that color image processing in terms of required smooth and a sharp process. Okay, so that is the best example is here. Best example is here. I've shown you some of the pictures are here. You can go through this. So next, coming to the, I'm about to stop my today presentation with the help of some of the references which are help us to understand some more detailed presentation of our topics which we are under coming under the full, that is full color image processing. How this full color image processing will be considered for the digital image processing. Okay, so with this I'm very thankful for your patient listen, and I'm going to continue as per our syllabus. Okay, next topic. So we'll meet you through this ELRV video in next video next time. I'm very thankful to you once again. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.